So, take-home quiz. Starts off, I hope, fairly straightforward. Hopefully you found most of this fairly basic. It's going to get tougher, but that's okay. We're going to practice. We'll do my usual joke, my favorite student. Name the point represented by the following coordinates. -6, +4, -6, -6, +4. I'm pretty sure that's a D, 1 mark. 6, -3, I'm pretty sure that's a C, 1 mark. -2, 0. Ooh, I almost picked B. A, 1 mark. List the coordinates for each point. Point B is 0, -2, half mark for each coordinate. Point G is 1, 1, 2, 3, 4, half mark for each coordinate. It's got to be in the correct order. Point F is -1, 2, 3, 4, -1, 2, 3, 4, 5, 6. -4, -6. Point O is 0, 0. Hey, I got that one. And point H is -3, 1, 2, 3, 4, 5, 6, 7, 8. Are those right? Yeah? I have to ask because it's a bit awkward reading this on my screen. My screen distorts things a bit. You guys don't see that part. What points are in quadrant 1? Only point G. Quadrant 2, D and H, a half mark for each one. Quadrant 3, F. And quadrant 4, point C and point E, half mark each. Which points are between quadrants? A, O, B. Yeah, half mark for each one of those. If you're missing each one, you're missing 1 mark grand total. If you're missing a point, take a half mark off. If you miss 2 of them, sorry, you get 0. So far, so good? Hopefully. That's really, I think, mostly Math 9 review. Now we're graphing equations. It says, graph the following linear equations using the table of values method. Ready for a shortcut? I really don't care what you wrote for your table of values, Sam. I care did you get the line right. And in a couple of units, I'm going to flog this shortcut to death, but here is your first introduction. You ready? Read me the equation. -3x +5. Plus what? 5. That tells me on the y-axis there's going to be a dot 1, 2, 3, 4, 5 high. You'll learn this shortcut shortly. Read it to me again. -3. What's in front of the x? What number is in front of the x? Careful, the whole thing. -3. That tells me from that point that I know right there to go down, because it's -3 over 1. It's going to look like this. Yes? So, in terms of a table of values, I think -1 goes with 1, 2, -8, or sorry, +8. 0 goes with 5, and 1 goes with 2. But you know what? I'm interested in, can you get the line? Looks like that. All or nothing, sorry. Do we have to have arrows on it, Mr. Dewick? This time, no. Next time, yes, for sure. Because it does go forever. Turn the page. Oh, it says 4 marks just for that? Wow. Okay, then I got to change my marking scheme. I guess it's going to be 1 mark for each point, and then 1 mark for the line, and that's how you get 4 marks for that. Okay, I'm not making that worth 4 marks next time. Turn the page. The following examples are relations. In each case, state the independent, state the dependent, list the input, list the output. Now, our new word for the input and the output is domain and range. We're going to be flogging that some more today. State the independent variable. E, the dependent is F. List the input, 4, 7, and 10. List the output, 5, 9, and 4. How could I figure out which was dependent and independent from a mapping diagram? The arrow points towards the dependent. What about if they just give me points? X is the independent, Y is the dependent. So it's going to be X, Y, It's going to be 1, 2, 3, 4. It's going to be 2, 4, 6, 8. In fact, I can even tell you what that equation must have been. I'm pretty sure that equation was that, wasn't it? Looks like they doubled every x value to get the y value. It looks like 1 mark for each of those. So let's see. Is this going to be out of 8 on this page? And this is out of 4. That gives us 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I guess it is at 25. Each one of these is worth 1 mark. So that gives you a score. Can you put a score in the top right corner out of, count 'em, 25, please? More. Can you get out the homework on domain and range from last day? It was a continuation of lesson 4. We finally finished off lesson 4. So Jordan, if you're away, you should have the notes still, because it was a lesson that I handed out a few days ago. Then we pressed pause, we went elsewhere, and then we came back. So go hunting. It looked like that. It said U4, L4, domain and range. And once you found it, so I gave you number 1, number 2, we crossed out K and L, 3, 5, 6, and 8. So I'm going to start out with my usual song and dance. Hey, were there any questions? Now is your chance to ask. Yep. 3. Okay. So now we're talking about a specific situation. The domain is the x values, and it's the graph describes her walk where it looks like, now I got to read, on the y-axis is the distance from home, on the x-axis is time in hours. What's 1 square worth? Sorry? On the x-axis, what's 1 square worth? I got to do some thinking. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares make up 1 hour. What? Are you saying that there's 120 minutes in an hour? How many minutes? What? Nice. I think each square is kind of a weird scale, but I think from here to here is 5 minutes. Let's double check. How many squares should make up half an hour then? I think 6, yeah? 1, 2, 3, 4, 5. Ooh, there we go. Good. Now I can answer this question. First of all, the domain. My x value starts at 0. What's the biggest value? 1 minute 5, 1 hour 5 minutes, 1 hour, I think 1 hour 10 minutes, or 70 minutes. Yes? They said time in hours, so we'll go. What does it say in the back? Minutes or hours in the answer? I'm not that fond of this question because there's kind of weird, weird units. 1 hour 10 minutes. That's what it says. So, come here. Come on, pen. 1 hour, 10 minutes, and then I would say the time is between those two, and it does use up all the times because there's no gaps anywhere, yes? It touches. Is that okay? Range. That's how far away she was at any one time. It looks like she starts here and she ends here, and I need to figure out what each square is worth vertically. I think each square is worth 1 block, yes? So I think the range is going to be 0 less than, touching. What would be a good letter to use for distance? I think so. Less than, touching, 11 blocks. I think, is that what it says in the back? I think. Or does it say it in English? From 1 to, I disagree, or do I have to, let me see. Yeah, I disagree with that 1 to 110. I think she starts at time 0, not at time 1. If it was time 1, that instead of right there would be right there. Yeah, it would be hitting right there at 0, 0 and starting off. And then I would say, oh, she sat at home for 5 minutes before she started. Here, I think it's between 0 and 1 hour and 10 minutes. I'll have to fix that. From 1 to 11 kilometers. Again, I think I would argue from 0 to 11 kilometers. Or, you know what might have happened? Because this is a Word document, it's entirely possible that this graphic slid over one square as I printed it so many times, because this was probably typed in Word 2002, and we're up to 2013 now. That's not math, that's just technology. It happens. The more graphics I do, the more things go wrong. Is that okay? Any others? All we are going today is practice. All we're going to do today is practice this. So I have a sheet for us to practice. So take a look at this sheet that I just gave you. I called it More Domain and Range Practice. All we're going to do is we're going to go through this. There's 16 questions. We're going to go through these in class together. And then I have I think a 4-page sheet with a bunch of these weird ones to practice. And I tried to stick some weird ones on here, Simi, as well. I already noticed one thing that I forgot to do. I forgot to number these. We're going to go in order, so follow along. It says, state whether or not the graph is a function. How about we just put y for yes or an n for no? You could write function or not function, but you may have picked up, Greg, I'm naturally looking for shortcuts and abbreviations. And then give the domain and range. Okay. First graph. And I can zoom in, I think, and fit it. Yes, I can. Function or not? Underneath, we'll do the domain and the range. How far domain is left, rights. How far left does this graph go? I heard someone say -8, and I heard someone say infinity. Which one's right, and what's the key? How can you tell? Okay, the fact that there's arrows, and you're going to see some later on, Sam, where I put big fat dots on the end, and that's my way of saying it stops here. If I put arrows, we have to assume it continues on, which means I think it goes to -infinity. How far right? Positive infinity. Any gaps? You're going to see some later on that do have gaps. We're going to look at the weird ones. So we would say between -infinity and positive infinity. In English, we would say all reals, but here's what we write. It's domain, so it's x's. That funky little e, r. Range. How low does this graph go, Sam? Yes. How high? I've scrolled down a little bit, but you know what? The range is also all real numbers. That means the height of 3,217,000.64913 does show up on this graph. Every single possible real number shows up on this graph. And we write that as, oh, it's range, so we'll use the letter Y, that curly E, R. That really says Y belongs to all real numbers. So that little funky E is an abbreviation for belongs to or is a member of. All right. This one. Function or not? It is? Yay. Yes, Y for yes, N for no. Domain. -infinity to positive infinity. How are we going to say that? Yeah. All real numbers. Ah. Range. What? Only one height appears on this graph. So here we would actually list it. We would say with the funky brackets, just 5. That's the only height that appears. So is it possible to be infinite and discrete? Yep. At the same time? Yep. In fact, all of you are graphing that right now. If I graphed for all of you right now, your current speed as a function of time, how fast are you all traveling? Sorry? Or if we, you know what, if we graphed your distance from home right now as a function of time, are you all a certain distance from home? Yeah? Is that distance changing at all? So that graph would be the height of whatever your distance from home is, constant. That's you all right now. All of you are both infinite and discrete. This one. Hey, try this one on your own. Oh, function or not, first of all? Sorry? Function or not? No, does not pass the, remember the vertical line? It doesn't pass. In fact, it is a vertical line. You're going to find, who has the graphing calculator in this class? Is it someone? Your calculator won't graph a vertical line. It can't. The software can't handle it. It's not a function. There are fake ways around it. If you're ever bored sometime, in about a month and a half, I'll show you a cheat on how to use that to make it look like it's a straight line. You do a line with a slope of like 10 million so that it almost looks straight to the naked eye, but it's technically not straight, and your calculator can handle that okay. Anyways, not a function. What's the domain? What's the range? Y, all reals. This shape, an eyeball kind of a shape, actually an ellipse. Sorry? Nope. Many interesting shapes aren't functions. Okay. I don't think the domain is infinite this time. I think, Jordan, it's between two values. Right? Alex, my friend, how far left, because we said we always do smallest then biggest, yes? Domain is left, right? How far left does this graph go? Touching? Yeah, I put dots there on purpose, big fat dots, because we noticed in our notes you kind of had to guess. So in this one, I made sure I put a big dot there. Touching? Yeah. How far right does this graph go? Touching? Yeah. Any gaps in between? Say no. Right? There's no holes in the graph anywhere. Like every single x value does have something above it. Yes? A point above it. How are we going to write that? So we said to write these in-between statements, it's going to be smallest value, leave a space, biggest value. To show that x is the values in between them, we actually put the x in between them. And then I said, if you always write the smallest and then the biggest, it's always going to be pointing that way, pointing that way. It's going to be a less than, less than. Oh, and then we asked, touching or not? Touching on the left, Marcus? Less than or equal to, which really means or touching. In English, Brady, we would say this. It's all the x values between -4 and +4 inclusive, which means including -4 and +4. Because technically, the word between doesn't include the ends. If I say, who's sitting between Brady and Darian, none of you would say Brady, Amber, and Darian. All of you would say Amber. Right? Right? And that's correct. In math, if I say what's between two values, we don't include the ends. What if I said, who's sitting between Brady and Darian, including them? Then it's all three. Range. And Amber, we all feel your pain. Range. How low does this go? Now this is my sloppy drawing, but I did put a big dot on the bottom there to show that it's supposed to be touching right there, even though you can see a tiny gap. So let's assume it touched 0. That's why I put that big dot there. How high? So we're going to go 0 less than, its range, y, less than 6, touching, touching. And then we move over a page. Is that what it is for you guys? Yes? We start getting some more esoteric, some funkier ones. By the way, Mr. Duick, are there equations? There are equations for all of these. If you ask me later on, we're done the lesson, I can show you how to graph a few of these. Not on a graphing calculator, but I've got some software on my computer that can graph what are called implicit functions, things that aren't functions. Function or not? This is the next one, yes? Let's see. Yeah, I think we're good. Domain. Brody. Careful. I don't think it's negative 8. Is it? 2, 4, 6. It's negative 7, isn't it? Negative 7. Less than. Touching? Touching? I put a big dot there, yeah. X less than touching? How far right? This graph exists between negative 7 and positive 5, inclusive. What about the range? How low? Negative 2. Touching? Yeah, in fact, there's a whole line on the line negative 2, a little horizontal chunk there. How high? Positive 8. Touching? Yep. How would you write that? Yeah? Let's try the next one. Our old friend, the parabola. Function or not? Yep. Now, you might argue, hey, Mr. Duick, it looks like right here that it touches more than one place. You have to trust me, the parabola, it gets steeper and steeper, but it never quite hits vertical. It's close, but never quite gets there. You'll never quite touch in the same place. So this is a function. Domain. Now this graph is going like this, so how far left and how far right will it eventually go? Yeah, I think this has a domain of all reals, x, funky curly e, r. What about my range? Is the lowest. Touching? Yes. So what we really want to say is everything above what? Everything above and including or equal to negative 5. How do we write that? Well, it's range, so I'm going to put a letter R. Above. If you're above something, are you bigger than something or smaller than something? We're going to write this. Y is bigger than or touching, above or touching, negative 5. Now, if you get your greater thans and your less thans mixed up, remember I told you a dumb way, this is what works for me. There's that, your teacher probably gave you the bird alligator thing, which never worked for me because my brain works weird. Did your teacher do the bigger mouth eating the, no, or whatever? You guys, some of you are nodding. Mark, it never worked for me, Marcus. Like I never figured, because my brain works weird. But here's what I came up with. What capital letter is that? L for less than, which looks an awful lot like an L on its side. This is less than that. Don't want to do that, Mr. Duick. Don't do that. Come on. Let's try this again. You can see some of the graphics issues that occasionally crop up. Ooh. A sideways parabola. Actually called an inverse parabola, you'll learn next year. Sorry? I agree. Sorry? Brody, you're right. Say it louder. I almost agree with Brody. Brody said, hey, Mr. Duick, I think the domain is x is bigger than... because Mr. Duick put a dot there, or touching 6. What if it was pointing to the left? What if it was this thing flipped that way? Oh, it would be everything less than or touching 6. What about the range? I think it's heading every height. Function? Nope. Oh. Domain. Now, when it's horizontal, there's also another, because kids get the greater than, less than mixed up. There's another way when it's horizontal you can remember. You'll notice my domain is going that way, and this also points like an arrow in that direction conveniently. That doesn't work vertically, unfortunately. Sorry. Anyways, less than or touching 6. The range, all reals. Turn the page over, I think, yes? Function or not? Where? Oh! Right here. Nice try, Mr. Duke. Domain. Here, I just got to list them. And it's easier just to go from the left to right. So I see a -8, that's supposed to be, comma, -7, comma, a -4, a -3, a 1, a 3 several times, and 7, yes, is that right? -8, -7, -4, -3, +1, +3, +7. Yeah, that's right. Yes, that's right. Range. Again, we're going to list them smallest to biggest. So start on the bottom, work your way up. I see -3, -2, +1, +2, +4, +6, and +8. A discrete or a disjoint graph. Discrete was the fancy word we used for those. Can't connect it. Ooh. How many graphs are there really in this question? There's 2 separate little curves. They come from one complicated equation. There's 2 separate little curves. Probably for part of this, we're going to have to use 2 statements. Let's see. Function or not? No, that I can get. How far left does this graph go? How far right? Does that mean it's all reals? Not this time, because can you see there's a big gap right here where no x values get used up. The only way I can do this, I have to answer it with 2 statements. I have to say, okay, you want the domain? I'm going to write this domain, everything to the left and touching what? X, sorry, I wrote X. I should have written D for domain, Mr. Duke. X less than or touching -4, comma. Or I'm also going to write this domain. Everything bigger than or touching 6. Mr. Duke, is there a way to write that in one statement? There is, but it's yucky and complicated. And it involves using not equal tos and not less thans and not greater thans. And sometimes you get into a situation where you have something that's not smaller than, which just gets, double negatives. So yes, it can be done. Nah, they're not going to write it that way on the provincial because it's just confusing. You do it sometimes in a logic class just for the nerdiness of it to see if you can get the double negative, but yeah. Hey, range. All reals. Yeah, range is a little easier. This is a hyperbola for those of you who are scorekeeping. Function or not? Definitely a function, yes. Passes the vertical line test. Ooh, what's my domain here? What's the smallest x value? Touching? So actually, Kira technically was wrong. The smallest x value is not -7. The smallest x value is -6.999999999999999999999, and in fact, as many nines as you want, I can get there. I just can never quite get to 7. That's what we're showing with that hollow circle there. So how will we write that? -7 not or equal to, just the less than sign. X not touching, just less than 2. That's everything between -7 and +2, but not including -7 and +2. That's who's sitting between Brady and Darian. Just one person. Brody, sorry. No, it is Brady. I got Brody mixed up in my other class sitting there. Did I call you Brody earlier? If I did, I apologize. My brain's tired. Apparently, I had 3 days off, too. Range. Oh, range, a little easier. Amy, what's the only height that appears on this graph?
7.
Lucky number 7. Oh, boy, that's terrible. I can do a better squiggly bracket than that. Mr. Deck! Yes, Amy. If we just did, and didn't put the squiggly bracket, would you take marks off? Probably not, but I'm getting used to it because that's probably how they'll write it on the provincial, right? Well, that was kind of cool. Ooh. How many graphs do you see here? How many statements do you think I'm going to have? Probably. Function? Mm-hmm. Domain. Going to be 2 statements here. Let's do the first line. How far left? Negative. The first one, how far left? -8. How far right? -4. Touching. So I'm going to write that as -8 less than x less than -4, comma, or include also. Look at the second line. How far left? +1. How far right? +5. Touching. Oh, what if I had this? Touching there. I could deal with it, but I didn't have that. So let's get rid of that. Ooh, what's the range? How many heights appear here? Only 2. Oh, I guess we're going to list them then. 3 and 5. 7, that's what I said. Can't you read my writing? Good gosh. By this time of the year, you'd think you'd be able, here, I'll make it very careful. 7. Sometimes my 7s sound like 5s, sorry. Next one. Is there a next one? Oh yeah, whole new page. Ooh, ah! Not a function. Domain. Range. Sorry? Domain, -4, comma, 2. Yeah? Range. I think, again, I'm going to have to do this in 2 chunks. By the way, you won't always, and I'm going to show you some in a second where you don't have to do it in 2 chunks. But for now, I think we're going to say the lowest we get is -7. We're touching. It's a y value because it's a range. Up to -2, but not touching. So no or equal to, comma. The lowest we get is +3. We're definitely touching there because they shaded in that circle. The highest it's a y value, so it's a range. The highest we get is +8, not touching. Dunk. Function? Yep. Try the domain and range on your own. I'll do them up here, see if we get the same thing. Touching, touching, ending, ending. I said that. -5 less than or equal to x less than or equal to 1 for the domain. For the range, 2 less than or equal to y less than or equal to 7. Touching, touching. Yes? A couple more weird ones and we're done. I like this question. I like this question. I like this question. First of all, function or not. By the way, don't write this down, but look up. Now, function or not. Right there, suddenly it fails the vertical line test. So just keep your eyes open is what I'm saying. So function or not? Function. We're going to do the domain last. Let's do the range first. Because I'm pretty sure only 3 heights appear here, yes? -7, -2, and 7? That's supposed to be 7 high, by the way. That's, again, my bad drawing. Sorry. 7, yes? -2, no, sorry, -7, -2, and +7. -7, -2, and +7. Domain. How many graphs are there on here? Okay, but now I want you to use your imagination. I'd like you to imagine that I slid this guy right to there, and I slid this guy right to there. Can you see that this could actually fill in that gap right there quite nicely, and it would fill in everything right to there? And if I slid this guy up, this point would color it in, because that would color it in right there, and we would end up, in fact, I think we would end up with something that looked an awful lot like this. Shaded in, no gaps, and a hollow point. You see it? I'm going to argue, even though actually there's 3 separate graphs, because if I move these up and down, I can form them into a line with no gaps in between. Even though there's 3 separate graphs, I can state this in one statement, I think. I can say the farthest left we go is -8. See it? Touching or equal to. The farthest right we go is what? +4. Touching, not or equal to. And there are no gaps, no holes in between. Every single point in between does get used up. Yes? I can say then that the domain -8 touching, x because it's domain, all the way to positive 4, not touching. No gaps, so I don't need to actually write them separately. Now, I did that on purpose. I made sure that if I slid those lines up and down, they would join together with no gaps. One more? One for the road? Last one. Function or not? No. Domain. I think only 3 x values show up. I think -5, comma, -2, comma, und 4. Yeah. Range, and now you're alert for it. Can you see that I can slide this guy right to there, and I can slide this guy right to there, and it would color in that one, and this hollow point would get colored in by that guy, but I think this one would stay hollow, and this one would stay hollow. Yes? So how can I say that? How low does this go? Touching? Nope. How high? 9? Or are you German saying no? Touching? No. Any gaps in between, actually? -8, not touching. Y values, not touching. +9. Everything in between. So I have a sheet of a bunch of these for you to practice. That's your homework, and you'll get it done in class if you hustle.